In this video, we will look at isotherms on a pressure versus volume plot. This is often called a PV plot. So I have a couple of examples here. Suppose we have, at this pressure of 4 pascals and a volume of 10 cubic meters, we have a gas at a temperature of 400 Kelvin. What will happen if we move, like decreasing the volume? So taking our 10 cubic meters and compressing it, but keeping temperature constant. What will happen to the pressure? We can see that by looking at these ideal gas laws. I'm going to use this one. It doesn't really matter which one, but this is a sealed piston. So if I look at this, PV equals NKBT. N, since it's a sealed piston, N will stay constant. KB, that's also a constant. So I can rearrange that. So PV over T is NKB. And if both of these things are constant, then P times V divided by T also is constant. So if I move from one place to another, I know that this has to be the same. So for any two positions on this graph, if I start here with some pressure 1, volume 1, and temperature 1, and I move somehow, so for example, decreasing the volume. When I reach a new position here, I know that pressure at the new position 2 times V2 divided by T2 has to be equal to the original. Now in this case, we're looking at constant temperature. So constant temperature means that T1 equals T2. So if I move along what's called an isotherm, keeping the same temperature, this direction, I would say my initial pressure times initial volume has to be equal to final pressure times final volume. So for example, if I went from 10 to 5, my volume went down by a factor of 2, that means my pressure has to go up by a factor of 2. So instead of being 4, it would be here at 8. So 5 and 8, there should be a point here. And if you plot other positions along here, what you'll find is if you keep the temperature constant and decrease the volume, the pressure will follow a curve that looks like this.